So I'll now show using Proc Univariate, which is a bit more sophisticated. So we just say we're going to do a univariate, this Proc Univariate, by treatment for the signal. When I ran that, it always takes you right to the end of the output, so you have to kind of scroll up to get to the top of it. So we've got the mean, and again, I mean, we've got a lot of the statistics that proc means would have produced, except now we could get these quantiles. We've sort of got the first quartile and the third quartile, along with the median, minimum and maximum, and various other quantiles coming in there. There's other statistics, if you're interested in that, they're not usually of interest to me. It's sort of got these measures of kurtosis and skewness and things to sort of help tell, that's presumably to help tell whether you've got a normal distribution for using parametric tests. Also it's not useful to us, tests to test whether the mean is significantly different from 0. So and a lot more in Proc Univariate, and again that can be output to a new data set as well. Proc Freq is about sort of obtaining frequency data. So here we'll obtain the number of observations at each treatment and time point. We did do that through Proc means, but you can also do it through Proc Freq. And the numbers at the top are the numbers of observations at each of the treatments and time points. By default, it also gives us the percentages in each cell. So there's 5.6% are in this cell of the whole table. And then these are sort of within the row, and so 21.6% of the 444 are on time point 24, and then it's done as a percentage of the column. And quite often you're not that bothered about those, and so there's always options to get it sort of personalised and how you want the data. So you might include these options: no row, no column, no percent, to get rid of those extra percentages, so you've got a simple summary of the frequencies. So Proc Freq, I mentioned, could do simple statistical tests as well, so I might as well just show how you would do that. We'll look at just one time point to make things straightforward. So we'll just look at time point at 48 hours, and we'll try and test using a chi-squared test if there's differences between the numbers of samples that had a positive rate compared to a negative rate. So to do that, I first needed to use this if time c equals 48, so you pick out just one time point, and then we create this variable which I've called rate c, and if that's greater than 0, then it's basically a variable which says, yeah, rate c is, you know, rate greater than 0. Otherwise, if it's less than 0, if the rate's less than 0, then we label it as rate less than 0. So we've got a binary variable there, and we'll use Proc Freq to analyse that using a chi-squared test. So we have the same Proc Freq with the table. We want it to be by treatment and this binary variable rate c, and we'll put in this option chi-squared. So that there's a chi-squared test. We run that. Oh, sorry, I haven't actually run this first bit, so I need to do the whole lot. You can run the whole program. If you just have a program you want to run, you don't highlight the data, you just run the whole thing pressing the little man. But quite often if you're working something up, you want to run bits of it at a time. So we'll just run this bit. And yeah, we get a table in a similar way to before with the frequencies, percentages that we're not really interested in, overall percentages, and by the rows and by the columns. And then we get our chi-squared test added on. But if you know much about the chi-squared test, you'll realise that probably with these zeros up here, there might be problems because we've got expected counts of less than 5, and it gives us a warning here that chi-squared may not be a valid test. So you'll probably be thinking, I should do a different sort of test, such as the Fisher's exact test. And so there's an option in SAS to do that, which is the exact option. So you can add that in. There's usually something in SAS, whatever you need to do, it's there somewhere. It's just a question of finding it. And as I say, emailing the help desk is a quick way to find things out. So that does the Fisher's exact test, which here is highly significant, which isn't surprising given the you can sort of see from that table that the numbers on each treatment with a rate less than 0 is quite a lot higher on treatment C than on the other 3 treatments. So it's not a surprise to find that the Fisher's exact test was significant here. I mean, the chi-squared test was significant, but we had the problem that it wasn't really a valid test because we've got low expected counts in some of the cells. Just spend a few minutes looking at the tabulate procedure, which is the one where you can sort of do fairly well customized tables. So this first bit of code here is a sort of table without any customization really. Categorized by the time point and the treatments. The variable that we're interested in is signal, and then this statement here sets out the table. So first of all, you give the rows in the table are going to be the treatments, and the columns are going to be signal by time, and our summary statistic is we want to get the mean of the signal. I'll run all that. So that's the end of the table we get. It's not laid out particularly nicely. It's using a standard format, so it sort of laps onto, you know, over the end of the line, and it keeps putting in mean at every stage. So we want to make that look a bit nicer. So we'll start off by formatting the data. So this F thing says we want to have slightly, I think the default format is probably 16. We want to have narrower columns, and we'll make them length 9. We'll again ask for 2 decimal places because that was appropriate for the signal that we were summarising. So we'll just do that to start with. So we've now got it all on one table, so it makes it look a bit better, but we want to go on and sort of improve that further. So we'll add in a label. We can do that for the means. We get rid of that annoying, you know, you don't really need to say, you can put this in the title, you don't want a mean coming in for every column unless you're using different summary statistics for different columns. So if we put in this label mean equals blank there, we get rid of that. So that looks a bit better. We might want to, this is the variable name treat, we might want to improve that as well. And we could have put that in this table statement, but another way, if you find it easier, you can have just a list of labels for the variables using this label statement. So we'll label the treatment that way, and we just get a better label for the treatment coming in there. You can add a title to your table, not surprisingly using a title statement, so that just gives a title. You can have a whole list of titles if you find it helpful. There's also a footnote statement, so you can have footnotes as well. So we've now got a title coming in up here. You'll notice it always puts the date, and that's actually a page number, but you can get rid of that. So there's an option to get rid of that, which I haven't used here, which is sometimes something you want to do. We can specify the length allowed for the left-hand side labels, because you might look at this and think, I didn't need all this space for these treatment labels. Maybe I can shorten this column. And there's something called the RTS option. I'm not sure why RTS. Most of the names SAS uses are intuitive, but that's not. So we specify that we want that to have 24 characters, and if we include that, it's a bit hard to tell, but it has made that it has varied that length a little bit from what the default was. I hope that gives a bit of a feel for how you kind of operate SAS and sort of add bits into the code.